dear students, welcome back to MKG Online Study and e-learning platform. Okay, so what if I told you your office network has a family tree, like an actual root, actual branches, actual hierarchy? Sounds wholesome. It's not. Let's get into tree topology. Tree topology, it's giving family tree. Let's break it down. With that you can show in this picture. What if your network had an actual family tree? One root node up top branching down into smaller hubs which branch down into your actual devices. Honestly, it's just star topology org chart. Parent, children, grandchildren all wired in. So a tree topology is a variation of star. As in a star, nodes in a tree are linked to a central hub that controls the traffic to the network. However, not every computer plug into the central hub. Majority of them are connected to a secondary hub, which in turn is connected to the central hub as shown in this figure. So this is our central hub and these are, you can say, the secondary hubs. So majority are connected to this secondary hub and secondary hubs are connected to the central hub. Central hub in the tree is an active hub which contains a repeater. The repeater amplify the signal and increase the distance a signal can travel. The secondary hubs may be active or passive. A passive hub provides a simple physical connection between the attached device. So, a hierarchical layout where one root node connects to secondary hub, which connect to individual devices like branching, growing of a trunk. So, this is our tree topology. Now we will see how data climbs the tree. So, how does actually it moves? Step number one, your device sends data up to its parent hub, not sideways to some random hub, neighbor. Step number two, if the target isn't under that hub, it just keeps climbing toward the root. Step number three. Once it hits the nearest shared ancestor of both devices, it changes direction. Step number four. Data heads back, down, branch by branch until it lands on the target. Same branch, opposite sides of the tree, that's the longest way round, all the way up, all the way back down. So the if this particular device wants to send data to this one, then first data will go here, then it will go here, then here, then here. So first all the way up, then all the way down. This is how data will climb the tree. Next is characteristics of the tree network. Strict hierarchy. Every node has exactly one parent except the root at the every top. It is essentially star topologies change together through a shared backbone. Depth equals to number of hierarchy levels, width equals to number of branches or how many branches sit at each level. New branches can be added without disturbing devices on other branches. The root and every immediate hub above a device is critical to that device stay online. And the bigger the tree, the more predictability, cable length, and node count is scaled. So cable length and node count both scale predictably as the tree grows. Function across the hierarchy. Every level's got a job. The root node sits at the very top, often the thing connecting your whole tree out to the internet. Intermediate hubs are the branches forwarding traffic between the root and their own section like mini traffic managers. Leaf devices are the endpoints, your actual laptop, printer, phone sitting at the outer edge. And just like other Hierarchical design, hub along the way, clean up and boost the signal. Further, it gets from the root. So, signal regeneration. Problems in the tree topology. Now, the real talk. Problem one, the scary one, root failure. A massive outage. Every branch underneath it just loses connection. The higher up the failure, the bigger the damage. Heavily dependent on the backbone. The whole thing depends on the backbone, and the main trunk cable has to carry traffic from every single branch, so it becomes a bottleneck fast. Problem number three gets complex fast. It gets complex quick. More levels means more hubs to configure and monitor. And problem number four, distinct devices equals to longer trips. Two devices on opposite branches have to take long way up and back down, which adds real latency. But here is why company actually built in this way. One, it scales beautifully. Add a whole new branch of device without touching anything else. It allows more devices to be attached to a single hub and can therefore increase the distance of the signal travel between devices. Second, easy to isolate faults. Two faults are easy to isolate. Problems usually trace to one branch, not the whole network. Third word, mirror how organization works. It just mirror how organizations already work, departments, floors, campuses. It fits naturally. It allows a network to fit naturally. Disadvantage, don't forget the trade-off though. Lose the root or trunk cable and you can lose huge chunks of networks in one shot. Every level of hierarchy needs its own hub and wiring. So cost climbs with the tree. More cable, more hardware required. And deep trees with tons of branches generally need near planning to manage, harder to manage at scale. So cabling cost is more and if the central hub is failed, the system breaks down. Now the real world uses. This isn't just a whiteboard diagram, it's everywhere once you know what to look for. Big office where each floor or department has its own branch of a central backbone. Enterprises and campus networks. Cable TV distribution. Cable TV providers distribute signal from a head and out to entire neighborhoods using this exact structure and ISP and WAN design. ISPs branch bandwidth from core routers down to regional then local nodes. Basically, every bit network is secretly a tree once you zoom out far enough. So now you know why the root node is basically the parent that everyone secretly depends on. If this made networking finally click, hit subscribe. I am mapping out a new topology every episode, and honestly, this family tree metaphor is about to get even weirder. So, dear students, if you enjoy this tree topology journey, like this video, share this video with your friends, and hit the subscribe button. See you in the next video. Next video is of comparison between star versus bus versus ring. Which topology is better? Thanks for watching.